Very much.
Yeah. So I'm Sirisha Bandla. I work in our DC operations office, which is a mighty team of 3. But our total Virgin Space portfolio employs about 1,200 people at the moment. So that was a great introduction, so I can go straight into what the Virgin Space portfolio encompasses. So last year we split the companies Virgin Orbit and Virgin Galactic. So Virgin Orbit in general is dedicated to providing a platform for small launch for small satellites. Virgin Galactic and the Spaceship Company are the companies that are working with human space flight and suborbital research and with our Spaceship 2 vehicle, which is actually missing from this picture. So we'll get into that later. So even though the companies are 2 different companies at the moment, we're still bonded by our founder, Richard Branson, and we're still bonded by our mission to provide increased access to the space environment for not only humans, but for research, science, and technology development. So I'm going to just talk a little bit about the small satellite portion first. So we've all been hearing about the small satellite revolution, and I know Tyvek's in the room, and they'll be talking a little bit more about it later today. But there's a lot of companies starting up that are providing services through small satellites, which is kind of a shift from how we've been doing it previously. There's companies that are already have their platforms in operations on orbit. Some of the companies you know, like Planet, Spire, Surrey. There's a lot of companies that are still in startup mode, but you've seen private investment go into this industry and into these companies. So they've really gone past ideas on napkins. That's really an indicator of where this industry is moving. So really excited about that. A lot of these companies are providing commercial services through their small satellite platforms, but we've seen a big opportunity to use these kind of platforms for science and research. So just a couple of examples, not necessarily CubeSats, but small satellites. Stereo was launched in 2017. It was an astrophysics mission. It was monitoring the brightness of nearby stars to aid discovery of exoplanets. I think most of us have heard about Cygnus. That's actually a constellation of small satellites that are looking at are gathering data on surface wind of our oceans, especially in the tropics area, to help us forecast and track storms, especially severe storms like hurricanes. And recently, which I think is very exciting, are the Marco CubeSats that launched along with the InSight mission to Mars. They're one of the first of their kind, 2 small sats going to Mars, and they're going to provide communication relays for InSight. It's not a critical component of the mission, but if it works, it's going to provide a lot of opportunities to incorporate small satellites for science and research and technology in the future. But that's not all. There's a ton of CubeSats in the works that are ready to launch. These are just a few. They're actually going up with our platform, Launcher One, in some of our early missions. These are CubeSats that have been built for the Science Mission Directorate, and we're really excited to provide them the launch service so that they can do their research. So our platform is called Launcher One. It's an air-launched rocket. It's air-launched off a 747-400 named Cosmic Girl, which is right here, and we got it from Virgin Atlantic, actually, and it was already named Cosmic Girl when we first acquired the aircraft, so we thought it was pretty aptly named already, so we kept the name. So we're based out of Long Beach. We're vertically integrated. We are manufacturing everything in-house and developing everything in-house. We're really looking to advance manufacturing techniques and a high flight rate to keep the costs low. In addition, we're using a 747, which is an aircraft that is known already and has a lot of expertise out there for that kind of aircraft. One thing I think is really exciting about our platform is that since it is a commercial aircraft, it's a 747, we can technically launch anywhere that we have a runway that can support us. And this is, excluding FAA regulations and safety, but so that we're going to take that into account when we choose our launch sites. But it really does open up the playing field for where we can launch, what inclinations we can get to, and how fast we can launch, and maybe even come do. And once its motor cuts off, it'll coast to apogee. That's really where payloads and humans will have about 3 to 4 minutes of microgravity. This is where a lot of the science you can see will be done, although we've had a lot of researchers interested in the hygiene portions of our flight as well. Once we get to apogee, we'll get into what we call our feather configuration. So if you think of a shuttlecock, whenever you do a shuttlecock, it always orients itself in one way on its way down, and that's basically the same concept for Spaceship Two. Through the feather configuration, we orient ourselves in the correct configuration for descent and re-entry. So once we have gotten to about 70,000 feet, we will get back to a normal configuration and glide back to the spaceport like a glider. And so Spaceship Two, we're really excited to fly humans. We have over 700 people signed up to fly with us already, but one thing I'm really excited about is the research possibilities. So right now, Spaceship Two can carry 6 people and 2 pilots to space altitudes and back, but everywhere there's a seat, we can take that seat out and put a rack of payloads, which is something we're doing through NASA Flight Opportunities Program and other programs where we can fly research. One thing that I'm really excited about is that we can definitely keep a seat in there and do human-tended payloads, which I think is a new concept for space-based research. That's not really something that we really have been able to do before for researchers to take up their payload and be alongside the payload and see data in real time, make adjustments in real time. So that's something we're really excited about. We signed an MOU with the Italian Space Agency to fly research and a payload specialist, so we're really looking forward to working with them on doing that. And then a quick flight update. So White Knight itself has flown 247 times. It's a workhorse, and it's been absolutely wonderful in its performance. Spaceship Two, we recently just had our second powered flight for Unity this past Tuesday, so and show a video that's better than me talking. Although I'm going to still talk in the video, so I shouldn't have said that. So a flight, as you can imagine, starts very early in the morning in Mojave, and that's where our flight test programs take place. I'm just going to mute it while they talk. But right now we are based in Mojave, California. That's where our teams are, and that's where our flight test program is going to be. The spaceship company will permanently be there in Mojave, but once we start commercial operations, we're going to move down to Spaceport America. Richard Branson did make it out to our flights. He tries to make it out to most of the powered flights. So he's very excited about the prospect of going to space and opening up space for all. So we take off in a main configuration, like a normal aircraft. It takes about 45 minutes to an hour for White Knight 2 and Spaceship 2 to get to altitude. Once we're at altitude, White Knight 2 will release Spaceship 2. So this was the release. The rocket motor ignites. For this flight, we burned the rocket motor for about 30 seconds. That got us to about 25 miles and Mach 1.92. So this is the 30-second burn. Very cool to think that people will be in there and payloads will be in there very soon. Our pilots are people, they were in there, but I meant like customers. So after we cut off the rocket motors, Spaceship 2 got into its feathered configuration so the pilots could do a few more checks off their test card. So this is Spaceship 2 in the feathered configuration. And once they're back in their normal configuration, they land like an aircraft. Beautiful landing by our pilots, per usual. Very exciting. And I know Richard Branson cannot wait to be able to fly into space as well. So we're always thankful for his support. And so this is Spaceship Unity, it's tail number 2, but we actually are in the process of making 2 more spaceships that will help us with our flight rate and be able to take more people and more payloads to space and back. So this is actually Bill and I in one of the spaceships that we're making at our facilities in Mojave. So we'll have 2 more coming up, and we're excited to get into commercial operations. And I'm happy to take any questions with that.
So on to the floor. Okay, so please go ahead, kids.
For launcher 1, you said it was low cost. Would you be able to give me like a ballpark number for how much it might cost to launch a CubeSat?
So for CubeSat, it'll be just in that depends, thousands to $100,000s, depending on what the size of the CubeSat is. When we say the baseline, our capability, which I think I failed to mention, it's about 300 kilograms to low Earth orbit. And for 300 kilograms, which is way more than a CubeSat, which is about 4 kilograms, 300 kilograms costs $12 million. So that's for the whole rocket. So CubeSat, you know what the CubeSat is, will be a very fraction of that.
Like a 1U CubeSat, 1 to 2U.
It'll be, I mean, it really depends on where you're going, but yeah. Not very much. It's something that we could definitely raise in a fundraiser or other methods. So it's really not out of the reach.
So at around what time in the future are you planning on start launching CubeSats?
So our first launch is planned for later this year. Our first launch will not really have anything on it. But the second launch, which will follow very shortly after that, will be our NASA launch that has CubeSats on it. So sometime this year. I forgot what the numbers were, so, okay, yeah, go ahead.
What's the difference between your business model and the old Lightspeed Pegasus?
So we are a lot cheaper than the Pegasus. We're using advanced manufacturing. We have liquid engines. Our flight rate is going to be much higher than the Pegasus flight rate, and all of that combined together is going to bring down the cost of our launches. So $12 million for a 300 kilogram launch is our baseline, which is cheaper than what Pegasus has publicly stated their prices are. I think before there's a, yeah, go ahead.
Quick question. What are the materials? What is Spaceship 2 made of? Is it composite
Is it all
and nickel?
composite? Yeah, it's a mostly composite vehicle.
And-
Same with Launcher One.
And does it glide back to Earth
Yep.
like the X-15 or?
Glide back to Earth, so no power. Once the rocket motor, so the rocket motor is a hybrid motor, so it's not something that we can relight.
I have a fairly simple-minded question. With the White Knight 2, you have a pilot on each side and 2 in the actual Spaceship 2?
So we actually have, it's not a simple-minded question at all, because they're identical. So we have 2 pilots that only on one side, and 2 pilots in Spaceship. The other side actually, is actually, the windows are fake. It's not real windows, so it's not actually right now in a usable form, but in the future, that could be something that we do is provide almost like a simulation of what it would be to fly in a spaceship, because the cabins are almost identical.
Pretty good flying then, because the tail is very extended.
Yeah, the White Knight 2 is a very, its performance is great, and it's, the capability that it has is perfect for Spaceship 2. In the past, we were actually looking at using White Knight 2 for Launcher 1, but we decided to make the rocket bigger, which was over the operating capability of White Knight 2, but a 747 can handle it no
Will
problem.
it take off from a normal width runway?
Sorry?
Will it take off from a normal width runway?
Yeah, we actually need a little bit longer length than the standard runway for abort scenarios, if we have to come back with a fully loaded spaceship, or for Launcher 1, same thing. We need a longer runway in case we have to come back with the rocket.
Is it worth putting in jet engines into the test aircraft rather than just have it glide down?
No, because right now, it's optimized for space travel rather than aircraft travel. So if there's anything that we need to do with an aircraft, we can do it with White Knight 2. But Spaceship 2 is specifically designed to go to suborbital space and back. So there's no purpose in us putting an engine.
Well, it might be safer because gliding without power is always a bit risky.
From the altitudes we're going, there's a lot of room for them to come back. Gliders are actually pretty common for sport and as a hobby, so it's not anything new or risky that we're doing, and our pilots are trained test pilots and have flown, in the military, so they're very comfortable with the spacecraft.
So your pilots are competing for the position to fly this wonderful spacecraft?
No, I think we all know, who can fly. We have a really experienced pilot corps, and I think they're all with the race that we're going to fly, I think we need enough flights for everybody.
Wow.
Because we have 2 more spacecrafts coming up, 2 more Spaceship 2s coming up, so there'll be a lot of opportunities.
It's wonderful.
Yeah, I think we're out of time, but
Yes,
I'll leave it up to you.
so I think we will can we say questions for panel or?
Oh, sure.
Yeah. Okay, thank you very much. And this is wonderful. So